Hi everyone, I'm Gabby Aquino, and this is my presentation on conic sections. So let's start with a general definition for conic sections. Conic sections result from when you intersect a plane and a cone. So first off, you can get an ellipse if you intersect the plane at an angle that hits both sides of the cone. So then you get an ellipse, and then you can also get a parabola if you hit the plane towards the edge at a greater angle. And then you can also finally get a hyperbola if you hit the plane at a vertical angle towards the cone. So then now let's get into ellipses. The definition for an ellipse is that any point P has the same sum of the distances to the two foci. So basically wherever P is on the ellipse, the distance F1 to P plus the distance to F2 to P is always going to be the same. No matter where P is on the ellipse, it's the same sum. So then the equation for the ellipse is going to be x squared over a squared plus y squared over b squared, and that's going to equal to 1. Some of the parts of the ellipse are going to be the minor axis, which is the line that's halfway through the ellipse, dissecting it on the shorter end. And then there's the major axis, which is another line that's dissecting the ellipse, but across the longer length. So then the points on the ellipse on the minor axis are going to have the coordinates of 0, -b, and 0b. And then the points on the major axis are going to be -a, 0, and a, 0. The foci are going to have the points -c, 0, and c, 0. So to derive the equation of the ellipse, you're going to take the sum of the different distances, the distances that we discussed previously, which is F1 to P and F2 to P, which is equal to 2a, and this is because if you make a right triangle with the foci and the minor axis, then a is the hypotenuse and a is equal on both sides, which is why it's equal to 2a. So then you can rewrite that and then square both sides, and then you'll simplify and square them again. And then, since we know that b squared is equal to a squared minus c squared, we can substitute that in and we can simplify it again, which is how we get the final equation, x squared over a squared plus y squared over b squared is equal to 1. Now, if the ellipse is vertical and the foci are on the y-axis, then it's just the x and y are interchanged, so you get the similar equation, but x squared over b squared plus y squared over a squared is equal to 1. So then now let's try a practice problem. We'll find the vertices and the foci of the ellipse, given the equation 9x squared minus 18x plus 4y squared is equal to 27. So what you're going to do first is you're going to rewrite it into standard form, which is the equation of the ellipse. So then you'll get x minus 1 squared over 4 plus y squared over 9 is equal to 1. So using the formula, that means that a is equal to 3, b is equal to 2, and then since c squared is equal to a squared plus b squared, c would be equal to root 5. So then the vertices of the ellipse are located at hk plus a and hk minus a, which means that plugging in what we already found, we'll get 1, 3, and 1, -3 for the coordinates of the vertices. Now the foci are found by the coordinates h, k plus c, and h, k minus c, which using what we found, is 1 root 5 and 1 negative root 5. Let's talk about parabolas. A parabola is defined as each point on the parabola is equidistant from a fixed point called the focus and a fixed line called the directrix. Here you can see the graph, which shows that at each point it is in fact the same distance to the focus and to the directrix. Now the vertex of the parabola is halfway between the focus and the directrix. The equation for the parabola would be x squared equals 4py. And then if we assume that a equals 1/4 p, then we can use y equals ax squared. So the focus of the parabola is going to have the coordinates of 0, p, and the directrix is going to be y equals negative p. That's when we put the parabola at the origin, so this is going to help us derive the equation for the parabola. Now if we take the distance from p to f and the distance from p to the directrix, those are equal. So we set them equal to each other, and then we can square both sides and simplify, and then that's how we get the final equation for the parabola. And if p is greater than 0, the parabola is going to open upwards, and if p is less than 0, it's going to open down. So if it's negative, it goes down. If it's positive, it's up. Now if the parabola is rotated, then we interchange the x and the y, so the equation becomes y squared equals 4px. And then if p is greater than 0, it will open right, and if p is less than 0, it will open left. And then the focus is also now at p0, and the directrix is now also at x equals negative p. Practice problem, and let's find the vertex, focus, and directrix of the parabola given the equation x plus 2 squared equals 8 times y minus 3. So to start doing this problem, it helps if we can assume that x plus 2 is just equal to big X and y minus 3 is just equal to big Y. So then the equation can become x squared equals 8y. Now we can compare this to the equation for parabola, which is x squared equals 4py. And then comparing those two, 4p would be equal to 8, and solving for that, p is now equal to 2. And now we know that the focus is at 0p, and that x equals 0 and y equals 2. So then if we substitute back in the original equations, we know that little x plus 2 is equal to 0, and little y minus 3 is equal to 2. Now if we solve for that, we get x equals negative 2 and y equals 5, which means that the focus is at negative 2, 5. So now to solve for the vertex, we can set big X equals to 0 and big Y equals 0. Now we can substitute in the original equations, and then little x plus 2 is equal to 0, and little x minus 3 is equal to 0. Now we can solve for x and y, and we'll get that x equals negative 2 and y equals 3, which means that the vertex is at negative 3, 0. Now we can solve for the directrix, which, using the equation, is y equals negative p. So we already solved for p, and we know that y is actually equal to y minus 3. So then if we solve for that, we input it in, y minus 3 equals negative 2, and then the directrix will be y equals 1. Shows pretty well that the vertex is halfway between the directrix 1 and the focus, which is at y is 5, and the vertex is y is 3. So that just shows that the vertex is going to be halfway between the two. So the final conic section that we'll be talking about is the hyperbola. The definition of the hyperbola is that the difference of the distances between a point, P, and the foci is always going to be constant. So that means that wherever P is located on the graph, the distance F1 to P minus F2 to P is always going to be constant. And we're going to take the absolute value of that, because if P is on the other graph, then it will still be constant if we take the absolute value. Now, the equation for the hyperbola is x squared over a squared minus y squared over b squared is equal to 1. Characteristics of the hyperbola is that the foci are going to be at the coordinates c, 0, and negative c, 0. And the vertex are going to be at a0 and negative a0. The hyperbola also has asymptotes, which are lines that they approach but never touch. And the asymptotes are going to have the equations y equals plus or minus b over ax. To derive the formula of the hyperbola, it's similar to what we did for the ellipses, except we're going to take the difference of the distances and we'll set it equal to 2a. Then we'll rewrite it, square both sides, simplify, square it again, simplify, and then since we know that b squared is equal to c squared minus a squared, we can substitute that in, and then we'll get the final equation, x squared over a squared minus y squared over b squared is equal to 1. Now if the foci are on the x-axis instead of the y-axis, we interchange x and y, and we'll get y squared over a squared minus x squared over b squared is equal to 1. This also changes the coordinates of the foci. They are now 0, c, and 0, negative c, and the vertices are 0, a, and 0, negative a. The asymptotes are now plus or minus a over b x. And now finally, for shifted conics, you'll take the equation and you replace x and y with x minus h and y minus k. We've already done an example of this with the ellipse, but if h is greater than 0, then the graph will shift right, and if h is less than 0, then the graph is going to shift left. And if k is greater than 0, the graph will shift up, and if k is less than 0, the graph will shift down. So now let's do a practice problem. Let's find the vertices, foci, and asymptote given x minus y to standard form, which is going to be the form that we're going to complete the square and then simplify it, and we'll get x squared minus h minus c, k. Equals the ellipse, the 5, 0, and negative. See, it'll be a hyperbola with vertices 7, 0, and negative 7, 0, with asymptotes y equals 3x and y equals negative 3x. Alright, so hopefully you paused that for a bit and tried it out on your own. Whether you did or not, here are the answers and it's all worked out. So for part A, we'll start by finding that the distance from a point to the line is going to be equal to x minus 1. This is because, given the directrix x equals 1, we know that the formula for the directrix is x equals negative p. So then, we know that p is going to be equal to negative 1. We also know that the distance from a point to the directrix will be y plus p. X. So that gives us x minus 1. We have that the distance from the point to the focus is going to be root x plus 5 squared plus y squared. Now if we set those equal to each other, because those distances are equal by definition, and you solve for it, you'll get that y squared is equal to negative 12 x plus 2. For the ellipse, we're given the foci and the vertices. We know that the vertices have the coordinates k plus a, h, and k minus a, h. So using that, we can find that a is equal to 8. Now we also are given the foci, which have the coordinates k plus c, h, and k minus c, h. So then we can find that c is equal to 5. Now using b squared equals a squared minus c squared, we can find that b is equal to root 39. Now that we know a and b, we can substitute those in to the equation for an ellipse, and we can finally get x squared over 64 plus y squared over 39 is equal to 1. C, for the hyperbola given the vertices and the asymptotes, we know that the vertices have the coordinates a, 0 and negative a, 0, which means that we can find that a is equal to 7. Now we're also given the asymptotes, which we know is equal to y equals plus or minus b over ax. Now since we know a, if we substitute that in, we can solve for b, which is going to be equal to 21. And now, having found a and b, we can substitute those into the formula for our hyperbolas, and we can get x squared over 49 minus y squared over 441 is equal to 1. Thank you for watching my video, and I hope this was helpful in some way.